So sadly we are also not getting any kind of signal from 3 kilometer away. We can easily communicate up to 2.2 kilometer using this kind of SX1278 LoRa module. Previously I was getting 2.2 kilometer range out of this LoRa module, but this time, as you can see here, from ground level we are already getting a signal from the transmitter antenna. Oh, we are getting a stable signal from 8 kilometer away from our transmitter antenna. It means our secret LoRa code actually works pretty well, and I don't know how far we can actually communicate using this LoRa module and this code, because 8 kilometer is already a huge, and I hope we can easily get up to 10 or 12 kilometer out of this LoRa modules and this coding hack. And you can also get this kind of stunning 8 kilometer range out of this 50 milliwatt SX1278 LoRa module just by modifying a few line of secret codes in your Arduino IDE. I am going to share the secret LoRa code with you. Also I will explain the code, and I will also show you the full range testing along with its proof. So if you are interested in this project and want to increase your LoRa range also, stay tuned in this video and let's start. In this video, I had tested the range of SX1278 LoRa module using this DIY dipole antenna and this quadcopter, and I got around 2.2 kilometer range out of this 50 milliwatt LoRa modules. And after uploading the video, one of my subscribers told me that he actually got 8 kilometer range out of these LoRa modules, and I was actually stunned how he can get 8 kilometer range when I am getting only 2.2 kilometer. And I asked him, he told me some secret coding hacks to increase the range of SX1278 LoRa module. So in this video, at first I will check the range of this LoRa module using the coding hack, and let's see how far we can communicate using this module, and then I will also give you the secret coding hacks in this video. So if you are also interested to increase your LoRa modules range just by adding some line of codes, stay tuned in this video and let's see how it goes. So this is my LoRa transmitter and this is my LoRa receiver box. Actually inside them there is SX1278 LoRa module along with some microcontrollers and other peripherals. If you want to know in details about this transmitter and receiver boxes, you can watch my previous video. I am attaching the link of this video in the description box and also in the I button. Now I will attach this dipole antenna with my transmitter and I will start transmitting. So let's start our receiver, and I had also started the transmitter. As you can see, it started transmitting, and if you see the receiver, here is a high power green color LED. When it will get signal, this LED will be green. As you can see, already our receiver has started receiving the signal from this transmitter module. Now we will attach this receiver under this drone and we will go away from this transmitter antenna and fly this drone high in the sky so that our transmitter and receiver antenna both can be in line of sight. And in this way, we will test how far these LoRa modules can communicate with each other. Also this time in this receiver I had also added a HC05 Bluetooth module inside it so that the receiver can send the real-time data with RSSI and SNR to our laptop via Bluetooth. As you can see, it is receiving data from the transmitter and the receiver is sending via Bluetooth. But I really don't know when this receiver will fly high in the sky. Will it be able to send data to the laptop via Bluetooth or not? So let's see what happens. So this place is around 3.1 kilometer away from our transmitter antenna, and I hope you can recognize this place. Previously we came here, but we were unable to get any kind of transmission signal from here. So sadly we are also not getting any kind of signal from 3 kilometer away. And this is our setup this time. This is the green LED, and I had extended its antenna so that this antenna, as you can see here, from ground level we are already getting signal from the transmitter antenna. Before we were unable to get any kind of signal, and this time we are getting signal from ground level. As you can see, right now my drone is high in the sky, and that is the receiver antenna, and you can see the constant green signal, and I am getting around minus 94 dBm of RSSI. It means we can go further because LoRa module can receive signal up to minus 148 dBm, and now we are getting minus 96 dBm. It means with the coding hack our LoRa transmission became very powerful. So let's go further. So this place is around 4.2 kilometer away from our transmitter antenna, and from ground level we are not getting any kind of signal due to this dense vegetation. So let's fly our drone here and let's check if we get any kind of signal or not. So as you can see, our receiver's LED is glowing constantly in green. It means we are getting a very stable signal from 4.2 kilometer also. Previously we get only 2.2 and this time is 4.2, and we will go further. So let's go further and see how far we can communicate. This place is around 6.3 kilometer away from our transmitter antenna, and let's fly our drone from here and see if we get any kind of transmission signal or not. So as you can see, from 6.3 kilometer away we are getting a stable signal from our transmitter LoRa module. It means our coding hack is actually performing super. So let's go further and check how far we can communicate more. So this place is around 7.3 kilometer away from our transmitter antenna. Now let's fly our drone and check if we get any stable signal from this distance or not. So from 7.3 kilometer away, we are getting a stable signal with our LoRa receiver. As you can see there, the green signal is constantly blinking. Now let's go further and test how far we can communicate using this. I am really stunned. So this place is around 8 kilometer away from our transmitter antenna, and again we are going to fly our drone and let's check if we get any kind of transmitted signal from here or not. Oh! So as you can see, we are getting a stable signal from 8 kilometer away from our transmitter antenna. It means our secret LoRa code actually works pretty well, and I don't know how far we can actually communicate using this LoRa module and this code, but it's not possible to me to go further than 8 kilometer. So in this video, I had successfully tested up to 8 km stable connectivity using this SX1278 LoRa module, and it is not possible and practical to me to test this module in further distance because 8 km is already a huge, and I hope we can easily get up to 10 or 12 km out of this LoRa modules and this coding hack. And also I had spent a lots of time and money on petrol, so it's not possible to me. I'm sorry for that. So now let's share the code with you, and I will also explain the code, and link of the code is already in the description box. So let's see the code. Okay, now explain our LoRa codes. This is our main LoRa configuration file which we have to follow for our main transmitter and receiver code. In this file, actually I had explained all of the parameters you have to configure in your code for your LoRa module. So let's start from the beginning. So you need two libraries. Here I am using LoRa.each library by Sandeep Mistry, and this is the link of the Sandeep Mistry's LoRa library here. And also we need SPI.h library because our this LoRa modules communicate with the microcontroller using SPI protocol or SPI pins. As you know, MOSI, MISO, SCK, chip select, and these pins, so these are called SPI protocol. Okay, so inside void setup, here is the lines we have to use to configure our LoRa module. If you read these lines properly, you will automatically understand how to configure your LoRa module for a extra long range communication. This is our first factor, which is a spreading factor, also called as SF, and this is LoRa.setup spread factor, which is currently 12. So its value can be from 6 to 12, any of this number. So higher SF means higher range, better sensitivity but slower data rate, and if you lower the SF count, it will finally shorter range, lower sensitivity, but your communication speed or data speed will be very high. So actually you have to trade off something in exchange of the actual range. You can also say this is the main problem of this extra long range communication, that we cannot transmit data in very high speed, but we have to trade off one thing to get another, as you know. So if you use a higher SF number, then your data rate will be slow, but you will get a very high range, and if your SF count will be low, then you will get a shorter range but very faster data rate. So for our extra long range, I had set it the spread factor for 12. Now the second is signal bandwidth. If your LoRa module is transmitting in a higher bandwidth, it can actually send a lots of data in a time. That's why signal bandwidth is very important. In this code, I had selected signal bandwidth 41.7 kilohertz. You can select it between these numbers as possible. If you select a higher bandwidth, your receiver sensitivity will be low, resulting less range, but you will get a very high data rate. And if you select a lower bandwidth, you will get a very high sensitivity in your receiver, resulting a very high communication range. But also you have to consider that don't keep this bandwidth very low, because due to temperature and other factor, if your crystal shifts, in that case your transmitter and receiver both cannot be in a single frequency. In that case it can be create some problem. That's why I had selected 41.7 kilohertz bandwidth here. You can choose between any of these possible numbers. So this is bandwidth. And here is our next factor, which is coding rate. Coding rate is actually the error correction inside the code. If you select a higher coding rate, you will get a error free reception in your receiver end, and lower coding rate can contain some error in your reception. So I had selected it 8 right now. And next is preamble length. Preamble length means it will transmit something before your actual data transmission, and it will help you when you are operating in a very noisy area, or your SNR is very high, or your signal strength is very low. But also remember, it actually adds some characters or numbers before your transmission to let you know LoRa module that I am going to transmit. So if you select a higher preamble length, it will resulting a very high airtime or very low data rate. But in noisy condition, or when your SNR or receiver is very long distance, in that case this preamble length can be very useful. So for getting maximum range, I had used 16, and 20 is actually very high and it takes a lots of time to transmit small data. So you have to select this according to your condition. Anything it can be between 6 to 20. I had used here 16. Our next factor is since word. It is actually kind of a address for your LoRa module, and I don't recommend you to change this anything. Let it be what it is as it is. And our next factor is CRC. CRC is actually also a checksum for your receiver data packet, that if it is corrupted or not, how far I know. And our last factor is transmit power. This is the most important thing. You have to check on your LoRa module how much maximum transmitting power it actually supports. I am using SX1278, which is up to 18 dB. That's why I had selected 18 dB power. You can select between 2 to 20 dBm usually according to your LoRa module. Newer SX1262 LoRa modules support 22 dBm, which is 160 milliwatt, but older 1278 supports maximum 18 dBm, which is more than enough, because as you can see I had got a 8 kilometer range, and also this range can be extended. Actually I was unable to test in further distance, so 18 dBm is also good. And then our void loop will be started. So these are the all factors which you can also read to understand. I will also provide you this case in a Google Drive folder, and the link of the codes you can find in the description box already. Check that here. And now let's see how to use these lines in our actual LoRa code. So this is my old LoRa code, which I actually used to transmit and receive using my LoRa modules. Remember, you have to add these all factors in both of your transmitter and receiver codes, so that your both LoRa modules can be synchronized in a similar way. So this is my old code, and I had just added this line inside the void setup. So these are as it is, as you can see. And here I had started the serial monitor by serial begin 9600, and here I had started the LoRa module LoRa.setPin and LoRa begin. Here LoRa module had started. Now these are the same factors which I had shown you before. Here I had also mentioned which are the possible values for that actual configuration, and that's all. And other code is as it is. You don't have to think about other code that much. Only this much factors affect our LoRa modules configuration, resulting our final transmission range. So I hope you can understand this. I will provide you both of this transmitter receiver code and also this configuration sketch in the description box. Please check this out. And if you have still any kind of questions, queries, suggestion or anything regarding this video, let me know in the comment section, or you can directly message me on Instagram. My Instagram handle is already in the description box. You can check out that also, and I always used to reply you on Instagram. So if you have any question, queries, please feel free to let me know. So that's it for the coding part. So I hope you already understand the main trade-off or downside of this ultra long range LoRa module communication, that we are not getting that much higher data rate. Previously with short range communication configuration, if a string takes around few milliseconds to fully transmit, now with this long range configuration it take around 5 or 6 seconds to completely transmit that similar string. So the data rate will be very low, but it's important to reliably and errorlessly transmit the full string. That's why it takes a long time in long range communication. So that's only the downside, and if you are okay with the lower data rate, then you can easily use this LoRa module for 8 to 10 kilometer communication easily. And one more thing, these LoRa modules are very low power, 50 milliwatt or 160 milliwatt. They are very small power. That's why in urban condition, when there is no any line of sight between buildings or vegetation or this kind of stuffs, they cannot operate in a long range. But you always have to know that LoRa modules are made to be used in line of sight. So you have to place your transmitter antenna high in the sky, and if possible you also have to place your receiver antenna high in the sky also. That's how you can get a proper long range communication. So proper configuration with proper line of sight, you can easily communicate up to 8 to 10 kilometer using this small 50 milliwatt LoRa modules also. And I am going to test a newer LoRa module which is SX1278, which operates on 160 milliwatt instead of 50 milliwatt of this SX1278 in my latest video. So if you are also interested to watch this video, please stay tuned in my channel and do subscribe. And also special thanks to my subscriber Harshad Ghatke bhai. Actually he had told me that we can also use these configurations in Sandeep Mistry library also. Before that I knew that we can only use this kind of configuration in Radiolib library, but he actually told me that he had used this kind of configuration in Sandeep Mistry's LoRa.h library also, and resulting he got a 8 kilometer range. And after that I had successfully tested it and I got really more than 8 kilometer range out of these LoRa modules. So again, thank you Harshad Ghatke bhai. Hi, I am AkashWave, call sign Victory Uniform number 3 Hotel Alpha X-ray. I am an electronics and communication engineer and a licensed ham radio operator also. Now I am pursuing my MTech on microwave technologies, and I used to make videos on microcontrollers, microprocessors, sensors, IoT, ham radio, antenna making, antenna tuning, RF module, RC hobby, RC plane, drone and this kind of stuffs. So if you are also interested on this kind of topics, please consider subscribing my channel, and I hope you already like this video. If yes, please press the like button. And if you have any kind of questions, queries, suggestion or anything regarding this video, let me know in the comment section, or you can directly message me on Instagram. My Instagram ID is already mentioned in the description box. So that's it for today. Hope you like this video. I had already put the Google Drive link of this code in the description box. You can easily download the free codes from the description box. So that's it for today. See you on another video. Bye.